Welcome everyone to another episode of Quick Bites of AI. Today, we're diving into the world of AI and machine learning to explore K-nearest neighbors, or as the cool kids like to call it, KNN. So grab your snacks and hold on because, oh boy, this one's going to be fun. All right, so K-nearest neighbors is one of the simplest machine learning algorithms. It's like the friendly neighbor who always has sugar when you run out. Essentially, it's a method used for classification and regression. And by classification, I mean putting things into categories like Lego pieces. The blue ones go here, the red ones there, and regression is just a fancy way to say predicting continuous values, like the height of a plant depending on how much sun it gets. So, how does this work, you ask? Well, imagine you're at a party and don't know anyone, but you see a group laughing and having a great time. Naturally, you want to join them. KNN works similarly. When you have an unknown data point, KNN finds the K closest data points, or neighbors, and then lets you decide what group the new data point fits into based on what group the majority of the neighbors belong to. It's like, hey, you've got 5 friends all wearing hats. Maybe you should too. Now you might be wondering, why is the K even there? What a great question. The K in KNN refers to the number of neighbors we consider. So, if K equals 3, you look at the 3 closest neighbors. Picking the right K is like ordering at a buffet, too little, and you miss out on the good stuff, too much, and you end up with a mountain on your plate. Generally, choosing an odd number helps avoid ties in classification. But honestly, picking a K is a bit like picking avocado at the store. Challenging, but worth it. Let's talk about distance. No, not the kind you maintain from relatives you don't want to hug. In KNN, distance metrics like Euclidean and Manhattan distances are common choices to measure how close points are to one another. Think of Euclidean like a straight line distance, a crow flying home, if you will. Manhattan is more like, well, walking in grid-like city blocks, great for those who love a more scenic route. Now let's look at some of the perks and quirks of KNN. It's super intuitive, like a 2-minute recipe video, easy to understand and implement. No, seriously, you don't even need to train the model. Just feed it data and ask questions later. However, it's lazy. Literally, it's called a lazy learning algorithm because it only does something when asked. Oh, and it can be a bit slow with too much data, like that friend who just can't decide what toppings to get on their pizza. To paint a picture, imagine you're a new student at school. You notice most kids carry blue backpacks. You decide, maybe you'll also get a blue backpack to fit in. That's KNN. You're classifying yourself into a group by looking at your immediate neighbor's choices. Without too much thinking. In realness, KNN applies to tasks like recommending movies and identifying if that blurry image is actually of a cat, or which handwritten numbers are, actually 9s and not 4s. Now, let's address the million-dollar question. Is KNN the best algorithm for all tasks? Sadly, like using a hammer on a screw, KNN might not be the best tool for every task. It's crucial when the dataset isn't huge or when you need an easy-to-understand decision. But for huge datasets with lots of features, it might be a bit slow and sluggish. Also, it can be a tad bit sensitive to outliers, just like your touchy second cousin at Thanksgiving. And there you have it, folks. A quick bite into the fascinating world of K-nearest neighbors. Remember, in the vast landscape of AI, KNN is like finding the right pair of shoes. It fits perfectly in some scenarios, but isn't everyone's one-size-fits-all solution. So, while you chew on this, why not think about where you might use KNN in your everyday life? Thanks for tuning into this episode of Quick Bites of AI. Until next time, keep exploring, stay curious, and don't be afraid to ask questions. Catch you later.